All right, guys, so we worked on simplifying a single radical. So we're going to continue working through the radical stuff today and tomorrow. We're going to first look at multiplying them. Students usually do very well with multiplying. So if you have two radicals, as long as they're both under a radical, like radical 5 and radical 3, we can go ahead and multiply them together to get radical 15. So kind of rule of thumb, if you have two radicals, multiply them together first, then it's going to become 1, and then it's just like what we were working on already. Okay, so we'll try a couple. I may hop and skip through some of these examples though. So number 1, radical 6 times radical 15. So they're both under a radical, so we'll multiply. The radical is still there. So what is 6 times 15? 90. Good. Bless you. All right, and then from there is 90 perfect? No, it's not. So we'll do our factor tree. Yeah, remember all this from the other day? I know we kind of took a day away from all this. All right, so we went ahead and do our factor tree, and then we're looking for what? Pairs. So I have a pair of 3s, so they come out as 3. Then what do I do with leftovers? Multiply them, and they go in the fridge, right? 2 times 5 is 10. So we get 3 radical 10. All right, let's go ahead and jump to number 3. Again, I have a lot of examples, but I don't always do all of them. So what should we do first on number 3? This is where you guys can talk to me. What do we do first? We multiply. Thank you. So I have outside numbers, just like when we were doing all our exponent stuff, right? Those outside numbers, they multiply. So negative 2 times 5. It's negative 10. And then we have radical numbers. So we're going to multiply those. What's 6 times 18? What? 108. Okay. And then from there, we need to try to simplify that radical. So what do you multiply to get 108? That was like simultaneous. All right, so then that one's 2 and 2, 3 and 9, and 3 and 3. All right, and then we look for our pairs again. So we got a pair of 3s, so that comes out as a 3. Pair of 2s, that comes out as a 2. Only leftover I have is that 3, so a leftover 3 inside the radical. And don't forget you had that guy out front, right? That negative 10 has to come down as well. So the negative 10 times 3 times 2 is negative 60, and then radical 3. How are we feeling with multiplying? Pretty easy. It's kind of a continuation on of just a single one. Why don't you guys try number 4 on your own? All right, so first thing, multiply. We'll multiply our outside numbers. 9 times 6 is 54. Multiply the radicals. 14 times 21 is 294. And then we have to do our factor tree. Okay, so I'm just going to go 14 and 21 because I don't have a calculator in front of me, and that's just easier. Then 2 and 7, and then 3 and 7. A lot of you went, what did you, 6 and 49? Is that what a lot of you did? I saw more than one person split their 6 as 3 and 3. So be careful, that'd be 3 and 2. So more than one person did that. So looking for pairs, I have a pair of 7s, comes out of 7. I have leftovers. Leftovers go inside as a 6. And then I also had this out front. And what's 54 times 7? 278, thank you. And then radical 6. All right, do we need to see more examples like this, or are we okay? Quinn?
I don't understand where you're getting 3 times 7. Or, I don't understand where you're getting 7. Because it's 2 and 3. So 2 times 3 is 6.
Right, the leftover stuff that don't have pairs, they multiply inside. Yeah, the pairs come out outside. All right, does anyone want to see any more examples of multiplying? Okay. So then we'll switch gears just slightly. We're going to look at imaginary numbers. Has anyone ever worked with imaginary numbers before? Ooh, one person. I'm impressed. Maybe, yeah. Imaginary numbers typically are reserved for Algebra 2. Okay, so like simplifying radicals, all that stuff, that is an Algebra 1 concept, but imaginary numbers is Algebra 2. All right, so this actually doesn't show up until like Chapter 4 in our textbook that we're, loosely following. But I feel it's easier to teach you Chapter 4 if we kind of bring this in now. That way it's become second nature to you by the time we actually really need to use it. Okay? Did you guys read the cartoon? It's funny. Calculus, imaginary numbers, 11, 30, 12, all those. Is that what imaginary numbers are? No. It's kind of funny, though. Good. All right, so it is the square root of -1.
Somebody smarter than me thought of a really funny pun. I guess I'm just being the first person who describes amazing imaginary it's the thing for
I'll let you work on that. You can ponder that and let me know what you come up with. All right, so if I is equal to the square root of -1, what is I squared equal to?
I think, therefore, I'm equal to the square root of -1.
Well, if I equals square root of -1, if I would square both sides, right? We can do that with equations, makes them equal. What does a square and a square root do to each other? They cancel each other out. So I squared is equal to -1. That'll show up in a couple days, Monday or Tuesday next week, but we'll need to make sure we know that. All right. So let's kind of talk about all this then. So if I ask you for the square root, let's jump to number 3. That's the perfect one. If I ask you guys for the square root of -49, what would you tell me? No. Nobody wants to tell me it's 7 or -7? All right. Reason we have to have I, or imaginary numbers, is because of that instance right there. Square root of a negative. If you type it in your calculator, what's your calculator tell you? Go ahead and type it in. Depending if you have a scientific one or the graphing one, it tells you something different. All right. What did yours say?
Unreal.
Domain error, and the graphing one says unreal. If it's not real, it's imaginary. Okay. But your calculator doesn't know how to handle that. Because by definition, like if I asked you, like, what's the square root of 49, just positive 49, what would you tell me? 7. Is there another answer that could be? Or -7. We'll talk more about that later. But, right, because by definition, it's what number times itself gives you 49. Well, 7 times 7. Or -7 times -7. 2 negatives are going to make a positive. So either one would work. But here, what do you have to multiply to get a negative number? Good, a positive and a negative. So not the same thing. So we don't know how to deal with that. So what we have to do, based on like what all this is saying, we can split this. Right? I can split that as radical 49 and radical -1. Do you agree that if I would multiply those, I still get -49 under the radical? Right? Okay, what's the square root of 49?
Oh my God.
And what does the square root of -1 equal? I. So the answer to that is 7i. It is imaginary. All right, the further and further we go this semester, we use imaginary numbers all the time. They become second nature. They're really actually pretty easy to deal with. But one thing you're going to recognize, and I'll kind of throw this out there now just as an intro to it, they don't show up on a graph. Okay? As we get into things, normally like if you would graph a line where you can see where it crosses the x-axis and that's the answer to that problem. If the answer is imaginary, it won't cross the x-axis. Okay, we'll talk more about that as we go, but just something to think about there now. So again, number 1, if we come back to this one, if there's a negative under there, I can kind of separate that. Right? I can kind of pull that off to the side to kind of get it out of my way so I can still deal with the other part of it. So square root of 12, it's not perfect, but we can do our factor tree. So 3 and 4, and then 2 and 2. Okay, so for this one, I have a pair of 2's, so the 2 comes out. Left over 3, it's going to go underneath my radical. And the square root of -1 is I. Now, when you're pulling that I out, it's going to go with whatever number you pulled out front. It kind of acts more like a variable, right, where you wouldn't write like x2, you'd write 2x. The same thing. I could write I2, but it's not, it sounds funny, right? We would write 2I. One thing I don't want to see is I don't want you to do this. Technically, the way this is written, it is not wrong. But what happens if my radical got a little long? Then it becomes wrong. Yeah, right. Which is why try not to do that. Throw things out front that are not under there. That way we don't accidentally think it's supposed to be underneath a radical. Okay? So every time I do one of these problems, do I have to, my first step be to write this split? Do you think we can recognize, hey, there's a negative under there, so my answer has an I with it? Is that fair? Okay, because remember, I'm the lazy mathematician. I don't want to write it if I don't have to. So number 2, will it have an I? Yeah, it's going to have an I. So I'm going to keep that in my mind. It's going to have an I. Let's go ahead and just break down the 45. 9 and 5. Good. 3 and 3. So we'll take out a pair of 3's. So it comes out as a 3. The leftover 5 stays inside. Where does my I go? By the 3. Good. Now, if you're uncomfortable and prefer to split it off so you don't forget about it later, that's fine. By all means, go right ahead. I'm just lazy and don't want to write it. Okay, so how about number 4? I or no I? It will have an I. Anytime there's a negative under a radical, your answer will have an I. All right. So I know there's going to be an I. And if you want, you could put the I out front and then get rid of the negative, if that makes you feel better. I don't care. Whatever works for you guys. 108. What do you multiply to get 108? That's where you went last time, isn't it? All right. And then 2 and 2. 3 and 9. 3 and 3. So we got a pair of 2's that come out. Got a pair of 3's that come out. I have a single 3 that's left over, so leftovers go inside. And don't forget, we also have the I, because there was a negative. So that's going to be 6I radical 3. Can you multiply numbers together if one has an I and one doesn't? Think about something else that you've done in the past. What if you had this? Could you multiply this 2 by the 3x even though it didn't have a 3x or an x on it? Yeah, you could. Multiplying, they don't have to be alike. Adding and subtracting, they have to be the same. Number 5, I or no I? I. Good. All right, so again, if you want to put the I out front, that's fine. If that makes it easier for you, whatever works. 300, and my brain sees that as 3 and 100. But you can go either way. All right. I'm going to go 2 and 50, 2 and 25, and then 5 and 5. So we got a pair of 2's, a pair of 5's, leftovers. I have just the 3. And then don't forget we had that other number out in front. And depending on where you put your I, make sure I is included in that. All right, so that's going to give me, what is that, 20I, and then radical 3. How How are we feeling? Feeling all right? You okay if I skip and jump a little more? Okay. All right, let's jump to number 7. There's a plus sign in between there. We haven't touched that yet. All right, so can I add -2 plus square root of -20? Can I put those two things together? No, I can't do anything with that. Can you clean up the radical, though? Yeah. All right, I'm going to recognize right away there's a negative under there, so that's going to pull out the I. And then let's do the factor tree on 20. I'm going to go 2 and 10, and then 2 and 5. All right, so we got a pair of 2s. And don't forget your I. Leftovers is a 5. And then I'm just going to bring down that -2 plus that was kind of hanging out front I hadn't done anything with. Can I now put them together? No. Adding and subtracting, they have to be like terms. They would both have to have an I radical 5 attached to them in order for them to be the same. So at that point, I'm done. I cannot put those two things together. All right, let's go ahead and skip 8. Jump to number 9. Try that one on your own. All right, so I tricked some of you on this. All right, so we're going to do our factor tree. 2 and 4, 2 and 2. So I have a pair of 2s. I have a single 2, right? And that's my leftovers. What number is out in front? That's a -1 that just comes down. So that's going to make that -2 radical 2. If I had wanted there to be an I in that answer, it would have been written as the square root of -8. This would have given you 2I radical 2. This has a negative on the outside of the radical. This has a -2. Okay, so just make sure you're aware of the difference. Negative under the radical, that's imaginary. Negative outside, that's not imaginary. All right, number 10. 8 minus the square root of 289. Is that imaginary? No, that's not imaginary. There's no negative under the radical. All right. 289, is that perfect? It is? What is it? It's 17. Yeah, so that's just going to be 8 minus 17. The square root of 289 is 17. Are those like terms I can put together? Yeah. What's 8 minus 17? Good. That one was easy. Actually, the radical went away. I was able to put them together. Number 11, imaginary or not? It is imaginary. Now, every year students try to tell me that it's not, because they're like, but there's 2 negative signs. Won't those make a plus? Can you multiply a number on the outside of a radical with a number inside of a radical? No, that radical kind of holds it hostage. You can't touch that. Okay. What's the square root of -144? Just 12? 12i. Yeah, so this is going to be 3 minus 12i. Are those like terms that I can now put together? No, they are not. One has an I, one does not. Remember, I acts like a variable, so I cannot put those together. Number 12, imaginary or no? It is imaginary. Is 72 perfect like the last two? No. All right. So again, however you want to kind of not forget the I there. We'll do a factor tree on 72. I'm going to go 2 and 36, 6 and 6, 2 and 3. All right, so we got a pair of 2s, pair of 3s, a leftover 2, and you had this stuff in the beginning. So 2i times 2 times 3. Can I multiply these even though one has an I, one doesn't? Yes. Multiply and divide, yes. Add and subtract, no. So that's going to give me 12i and a radical 2. All right. How are we feeling about imaginaries and multiplying and all of that? Are we okay? Just out of curiosity, see what you guys think. If I had the square root of -2 times the square root of -5, imaginary or no? Can I multiply those two numbers together? Because they're both under a radical, right? Your first step, I told you, it's multiply them together. -2 times -5 would give me 10. So is it imaginary? No, it is not. Okay, so beware of that. If they're both negatives underneath here, you'd multiply them, makes it positive. But here, the two negatives do not make a positive. One's in, one's out. They don't work together that way.